All right, now we're going to start with our challenge problems number 4. This set, the first one should have been pretty easy. There it is. Should be pretty easy for you. The next one is going to be harder because this one's all about just organizing some variables here. So you should have this in front of you. What this question's asking you to do is just think about an elevator accelerating at the bottom and going up. It goes up with an acceleration over a certain time interval, and then 4 times that time interval, it goes at a constant velocity. So it's sped up to a constant velocity and goes at that constant velocity for 4 times the original time it took to accelerate. Then it decelerates, so it's a negative acceleration until it stops. So these, and it stops at this is very specific here, it stops at the same amount of time that it took to start at the beginning. So the first acceleration is the same as the last acceleration, except it's just negative. And the time it took for the first acceleration is the same as the last acceleration. And the time in between where there's a constant acceleration, well, that's 4 times that one single session of acceleration. So how the heck are we going to model this? And what are we really trying to find here? Well, it's it's pretty complicated, but I'm going to try to break it down for you. We really want to find the distance, or the change of position, or displacement. I should say displacement. That's what we want to find. All right, so let's get this whole thing started. Let me get the sketch up. There it is. All right. So let me just make a little graph to start off with. Let's do it up here at the top. So the very first, let's say that this is time. It's going along here. There's time. And the first, I'm going to just call this delta t1. And let's say this is positive acceleration, and this is negative acceleration. Right. Then this would be 1, 2, 3, 4. It should be the second time interval, and then we'd have another one right here. So what's going to happen here is that the first time interval, it accelerates, and then it stops accelerating, and it stays at that constant speed or velocity for 4 times that original time, and then it goes down, and then it drops down to a negative acceleration, and it lasts for just as long as it did over here. So what I'm going to try to do right now, this is 0. What I'm going to do right now is I'm going to break down each one of these chunks of time, and I'm going to try to describe how far this elevator goes up. So I'm going to find the displacement at which it goes up. Then what I'm going to do is I'm going to add all of those displacements together, and that should be your height. And then from that, you'll see you can use acceleration and solve for acceleration using height and time. So I'll just go through this. I'll just walk through this. And I don't expect you just to have looked at this at the very beginning and just understood it completely. This is kind of abstract, and it's not really clear exactly what's being asked of you here. So just what I want you to do here is just follow along, see if you can follow along, just straight through. If you need to stop and rewind or do something like that, that's fine. But try to follow along all the way through and just follow the logic through this. If you can follow the logic, that's all I want you to do. I just want you to have appreciation for, reasoning things out and using algebra. So here we go. So for this first time interval, I'll use red. So here it is. For this first time interval right here, I want to find what's gone on for this delta t. This delta t1, I'll call it. For that change in time, I want to know what delta s is. What is delta s? Well, we have that equation that we kind of derived before. It's 1/2 a delta t, I'll call this t1 squared, plus u delta t, I'll call that 1. Now the u is 0 here because our initial speed, our initial velocity is 0. So I get to cross it off right away. So I'm just going to cross that right off. Here's an eraser, I hope. Yeah. So right away, I know my delta s, let's make that a little bit cleaner. That delta s, was this right? Yeah, that delta s, and let's call this first section, I'm going to call this first section, I'll call it section, I shouldn't call it A, I'll call it section B. I'll call this section C, from here to there. I'll call that C, and I'll call this section over here, this time, interval, I'll call that D. Okay. So A, B, C, or sorry, B, C, D. So this is B, the time, this is the displacement for B. So if we would know the acceleration and we know the time, then we would know how far it goes. Right. Now I want to find how far you go for section C. I'm going to use a different color for this one. I'm going to use green. So green for this section here. This is going to be, I'll just cover this over here. This is going to be C. Awesome. Right. So this is just a constant velocity here. So what I can do is I can write this little equation. We know that, and it's the constant velocity, I can just use, it's the average velocity, same thing. So I'll just say the velocity equals delta s over delta t. And if I rearrange this, now it's going to be v times delta t equals delta s. Perfect. Right. So this delta t here is actually 4 times the t1. So I'm going to make everything in terms of t1 here. So this is the time interval 1, but it's 1, 2, 3, 4 times that. So this delta t here, I'm just going to replace with 4 delta t1. And the velocity, well, what is the velocity here? What's the velocity? Well, it's at a constant velocity. So what is that constant velocity? Well, to figure that out, we have to go back to this original interval right here and see, okay, well, how much did it accelerate, and then what's its velocity once it's accelerated? So to do that, I'm going to use a different color here, and I'm going to say, okay, during this time interval, what was its final velocity? So I'll use this little equation. A equals delta v over delta t, because that's just our acceleration equation. And in this equation, A equals, I'll just expand this, minus u over delta t. And this is delta t1 in this case. Here, there's no initial velocity, so this is 0. So this is A equals vf over delta t1. Right. What's vf? Well, vf is A times delta t1. So our final velocity that this thing is accelerated to is this, A times delta t1. So what I can do, since this is a velocity now that is constant, once it's gotten to this little interval, I can now plug this value, A times delta t1, into this velocity right there. So now this is times A times delta t1. Since that is our velocity, that's our final velocity after they've accelerated in the elevator to that point. So now this is going to all be pretty cool. So now our delta s is this. So this is our delta s. So our delta s is, let's just multiply these things out. This is going to be 4, let me see if I get this right, 4 times a delta t1 squared. So that is our delta S for this section right here. This is for C. All right. So we've got the delta S for B. We got the delta S for C. Now we want to do the delta S for D. So let's do the delta S for D. I'll do that in purple. So this is delta S right here. That's what we want to find. Right. So now I'm going to use this equation, the same equation I started with over there, for this interval over here for D. So for delta S of D, it's going to be 1/2 a delta t squared. Now you might be wondering, why did I choose this equation? Well, it's because I've been using this equation for everything else, and it turns out in the end, you don't know this yet, but it turns out in the end that it's simplified in a really nice way. So let's just go with it right now. And then I'm going to do plus u delta t 1. Now, I'm using delta t1 here because this section right here, as it said in the problem, delta t, this delta t is the same as that delta t, so I'm just going to call it delta t1. It's the same interval, it's the same amount of time. So I'm going to call it delta t1. Okay? So this is all good, except that this acceleration now, since it said in the problem is now negative, this whole term, turns into a negative. This right here is a negative acceleration. So this whole thing is going to be negative 1/2 a delta t 1 squared. Plus, now what's this u? The u is the same velocity as this was going at the constant velocity here. So this is our initial velocity, which was the constant velocity in the previous section here. So this is the same value. So let me use black again and move it on over here. So it plugs back in over here as well, which is pretty cool. It's very useful. So this is now a delta t 1 over here, and this whole thing then times this whole thing here times delta t1, just like that. So this term turns into a delta t squared. This is now 1/2 a delta t, let's use a 1 subscript there, squared. So what is this? What does this equal? This equals, well, you take 1/2. This is minus 1/2 a delta t squared plus a delta t squared. This is just going to be 1/2 a delta t squared. And so that is our delta S for D. So this is our delta S for D. The green is our delta S for C. And the red is our delta S for B. We're almost done there. Now all we got to do is add it up. So all these delta S's, I'm just going to make the argument right now. Here it is, that, let's go back to brown. The height of this building is, I'll use the same color here, delta SB plus delta SC plus delta SD. So it's this plus this plus this. That should be the height. That should make sense. It's the displacement in all those different categories. This is the height, I'm sorry, not the height of the building, but the height at which the elevator goes up for 6 floors. That's what it says in the problem. Okay, so what does this all equal? Now I'm just going to put on all these values here. So for delta SB, I'm just going to write in 1/2 a delta T1 squared plus, right over here, for delta SC, it's going to be 4a delta T squared plus this